The evolution of plastics. Mankind has over the last 6,000 years multiplied, spread out, and tamed nature. Learning from nature, he learned to exploit it to the fullest. Just like Adam was commanded by God to do, man turned nature into a garden and mountains into mines for his metal tools. With the help of tools, man was able to mine the plants and animals nature freely provided for him. Nature gave man wood to build with, paper to write on, and leather to wear. Like picking fruit from trees, man picked silk from silkworms, cotton from plants, wool and leather from animals, and glass from stones. Nature freely and unconditionally provided man with all the material he needed: the air, water, and rocks, with the plants and animals living on them. Lush jungles were buried deep and allowed to decay from carbohydrate foods for animals to hydrocarbon fuels for machines. These seas of fuel lay undiscovered until the machines evolved. Once the machines got big and strong enough, they dug deep enough like hungry dogs after a buried bone. They eventually uncovered seas of energy-rich hydrocarbon oils that were once jungles of carbohydrates millions of years ago. What was food for animals a million years ago became food for machines. Chemists, like painters mixing colors for a painting, have been mixing raw materials from stones, plants, and animals and creating mixtures of them in repeating attempts to improve on nature. Very soon on, after man started to mix materials, he was able to produce very many different types of materials. Alloys of metals. Iron with carbon forms steel, which forms stainless steel with chromium. Copper with zinc forms brass, and with tin it forms bronze. Silicate fibers like asbestos and rock wool are made like cotton candy. They are used for insulation. Fiberglass, made like a cloth, and fiber cement, made like cardboard, are used for roofs. Ceramic and concrete. Chemists have learned from nature how to mix different types of rocks and how to bake them like they were baking breads. The calcium carbonate from seashells cements the rocks together much like starch does in breads. And like the different pastries and breads, man makes different fake rocks from porcelains and insulating gloves to breast implants. Paper, cellophane, and rayon. Chemists have learned from nature how to use cellulose from plants to make many types of fibers, fabrics, and textiles. Inspired by nature's fossilized tree resin called amber, chemists have created linoleum. The main ingredient is solidified flaxseed oil from the linseed plant, which provides fibers to make linen. Pine resin, ground cork dust, wood chips, and calcium carbonate is added, and the mixture is allowed to harden on a burlap or canvas backing. The resulting material is very durable and flexible. It makes attractive floors that are cheap and easy to install, long-lasting, and easy to clean. Rubbers are hydrocarbon chains joined side to side by sulfur atoms, causing a material that is elastic. Sulfur atoms have similar shapes and properties to oxygen atoms, which join hydrocarbon chains end to end, causing a material that is strong. Plastics. The earth was mined deeper and deeper until oil called black gold was found. The once richly dressed carbohydrate chains decorated with oxygens and nitrogens were found as naked hydrocarbon chains containing only hydrogens. Chemists saw the opportunity to play God in resurrecting the hydrocarbons by dressing them up again like they once were when they were a part of life. These new materials, like clay, could be molded into any shape, so they were called plastics. Chemists dressed these naked hydrocarbon chains with atoms in ways nature had not yet tried, and they made many different kinds of plastics. Like the life form which plastics originated from, they were basically all the same, and yet all very different. Due to their relatively low cost, ease of manufacture, versatility, and imperviousness to water, plastics, like stubborn weeds, have displaced many traditional materials such as wood, stone, bone, leather, metal, glass, and ceramic. There are as many different plastics with different properties as different ways they can be dressed. Depending on where the single, double, and triple bonds are along the chain, and depending on where any additional atoms like benzene rings, nitrogens, oxygens, chlorines, and fluorines are hanging from it, determines the properties that the plastic has and if it can be recycled or remolded into other shapes or not. The plastics, polyesters, also called PES, are made by joining acids with alcohols. They make fibers and textiles so durable as to produce bulletproof mylar clothing and Kevlar armor. Polyethylene, also called PE, are repeating chains of CH2. They have a wide range of inexpensive uses, like supermarket bags and plastic bottles. Polypropylene, also called PP, is a repeating chain of C3H6 units. They make good bottle caps and are strong enough for pressure pipes and car fenders. Polyvinyl chloride, also called PVC, is a polymer with repeating units containing chlorine atom. By adding chlorine, the plastic becomes chemically resistant, light in weight, and cheap. It becomes very suitable for plumbing pipes, guttering, shower curtains, window frames, and flooring. The material's properties are so outstanding as to allow it to be molded with tiny scratches encoding all the sounds of an orchestra and choir playing for 15 minutes on the size of a plate. Adding more chlorine allows extremely thin yet very tough sheets like saran wrap to be produced that is ideal for food packaging. Polystyrene, also known as styrofoam or PS. These are chains of carbon with hanging benzene rings that are like bubbles of air, used for foam packaging to insulate against shock and temperature. Makes great food containers, disposable cups and plates, and CD boxes. Acrylic fibers are man-made polymers with the repeating NC3H3 unit. Adding nitrogen atoms allows extremely thin fibers to be made that are like wool and are used to enhance wool, cotton, and paints. Acrylonitrile butadiene styrene, better known as ABS, is a blend of acrylic fibers and styrofoam. They make a material light and durable for housing electronic equipment and strong and durable for making drainage pipes. Polyethylene terephthalate polyester, better known as PET, is a polymer chain containing C10H8O4 units. They contain oxygen for strength and benzene rings that are like windows to light, making them transparent. They are used in carbonated drink bottles, plastic films, and microwavable packaging. Polycarbonate, also known as PCs, is a polymer with repeating OCOO units. Saturating the carbon chain with oxygen atoms results in a highly transparent and highly resilient and shatterproof material, ideal for compact discs, eyeglasses, riot shields, security windows, traffic lights, and lenses. Polyurethanes, also called PUs, are a repeating chain of NCOO units. Replacing an oxygen by nitrogen in a polycarbonate fiber gives it a structure ideal for shock and thermal insulation, making it the most used plastic in cars. Polyamides, also known as nylons, or PA, are a chain of repeating NOC3H5 units. Imitating nature's production of polyamides such as wool, silk, and proteins, chemists make polyamides called nylon. Adding nitrogen with oxygen to carbon chains allows extremely thin and strong fibers to be made, which are ideal for ultra-thin stockings, fishing lines, brush bristles, and even car engine moldings. By dressing carbon chains appropriately, materials can be made with any properties desired. Glue molecules with very rough surfaces stick together like burrs from plants or Velcro from chemists. Materials can be so smooth that nothing sticks to them, like Teflon. Clothing coated with Teflon, called Gore-Tex, has holes that allow it to breathe like cotton, yet remain impervious to water like plastics. Gore-Tex is so smooth that it does not tear water droplets apart, keeping them big enough so as not to flow through the holes in the fabric. Chemists mix and glue different materials together to imitate materials made by nature, but they are not successful all the time. The tensile strength of spider silk is greater and more elastic than that of steel. An ant's brain functions better than any computers can and with less energy. More and more of our body parts are being replaced by plastics. Once chemists make polyamides that can replace those made by nature, then mankind will face the prospects of finding himself in a plastic body that could be resurrected at his will. This opens the door to immortality that raises questions about its immorality.